So my mission here is to make sure that you understand subnetting. Yeah, and I'm going to do everything possible to make sure that by the time you finish watching this video, you understand how to find your network IP, the broadcast IP, the first usable IP, the last usable IP, calculate your subnet mask, like very simple, in a very simple way, right? So that's my mission. Let's get right into it together. So this is the IP range that I chose. I chose something, I chose this IP range for, let's say, my VPN, right? If you are creating a VPN in AWS, you are supposed to choose an IP range, which is the IPv4 CIDR block, right? So this is the subnet that I choose, which is 20.0.2.0/24. Now, before anything, you have to convert these octets into base 2, right? So that you know the various bits involved. Now, when you see this /24, all that you are trying to mean when you choose /24 or when you are given slash something is to say that you are using that number of bits, you are reserving that number of bits for the network. Then the rest can be used as the host IP, and that is what you have to distribute, to give to hosts, and then to use for your subnets and all that you want to do. So there are 32 bits in total. So if out of that 32 you are saying that let's use 24 for my network, we should reserve 24 for the network, that means the rest left is for the host. Does that make sense? I hope it does. So whenever you see slash something, so for instance, if I do /2, right, I'm saying that use 2 of the bits here, 2 out of the 32 bits, use them for the network, and then use the rest, that's the remaining 30, to get my hosts for me. So plenty hosts for me. Now let me get it back to 24, right? So in order to understand this bits that I'm talking about, right, you have to convert this to base 2 so that you get the bits. The base 2 will give you the zeros and ones so that you get the bits separated out. So let's convert 20 to base 2. Let's do that right here together. So to convert to base 2, the number divided by 2. So we are converting 20 to base 2. So here we have the value that we get from the division and then the remainder. So the remainder is what will give us the base 2 that we need. So 20 divided by 2 is 10. Remainder 0. 10 divided by 2, 5. Remainder 0. 5 divided by 2, 2. Remainder 1. Because you know that 2, 2, 4, and it will be left with 1. So remainder 1. Now 2 divided by 2 will give you 1. 2, 1, 2. I heard you. Remainder 0. 1 divided by 2 is 0. Remainder 1. Because 2 cannot divide 1, right? So that's 0. And the 1 will still persist. So you put the 1 there. Now when you hit 0, like you've ended, because you keep getting zeros, because 0 divided by 2 is not possible. So that one too, you get 0, remainder 0. And because it's 0, you keep going and you keep getting zeros until you go and get all zeros, right? When you finish doing the calculation like this and you are writing it down as the base 2, you write it from bottom up. You don't write it from up down. Here is what I mean. Now before we proceed, you can see that we have only 1, 2, 3, 4, 5, 6, and every octet has 8 values in them. So we are supposed to have 8, but now we have 6. We can choose to keep going with the division so that we get the 0, 0, 0 to get the 8, but it's not necessary. Just understand that when the division has ended, or when you've reached your 0 and it's not up to 8, you just add extra zeros at the bottom to get the 8. So 1, 2, 3, 4, 5, 6, 7, 8. Good. So now we can write it out. Let's write it out here. So this will give us, I hope you are looking at it with me. Like I said, we read it from bottom up. So that's the same way we are going to type it out or write it out. Bottom up. 0, 0, 0 dot 1, 0 dot 1, 0, 0. Oh, sorry. No dot yet. That's in one octet. 0, 0, 0, 1, 0, 1, 0, 0. Please, no dots in the middle. It's when we are moving on to the next octet that will bring the dots, right? So that's for 20. So if you calculate 20 in base 2, this is a calculation, and you get 0, 0, 0, 1, 0, 1, 0, 0. So in order to understand, or in order to be sure that you have done the correct thing, you can convert it back to base 10, okay, to be sure that you've done the right thing. So let's try that shortly. Won't waste time on that. So converting to base 10, we pick the figures, multiply by 2 raised to the power its position. You will understand shortly. So we have 0 times 2 plus 0 times 2 plus 0 times 2. We are doing it from here, so mind you, this is what we are converting back to base 10. So the 0 is from here, the first 0, the second 0, the third 0. So now we are moving on to the 1. Okay, so plus 1 times 2 plus 0 times 2, 0 times 2 by that, plus 1 times 2 plus 0 times 2 plus 0 times 2. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I don't know how to type raised to the power on my keyboard. If you know, after watching this video, you can teach me, okay? But to convert to base 10, you start doing the raised to the power from the right. So 2 raised to the power 0. I'm using this sign to depict the raised to the power, okay? So 2 raised to the power 0 times 2. So let's count with me. 2 raised to the power 1. You start from 0. So 1, 2, 3. 2 raised to the power 2. 2 raised to the power 3. 2 raised to the power 4. 2 raised to the power 5. 6, 7. Okay, let's move this a bit. Alright. 2 raised to the power 0 is 1. Please. This is math. 2 raised to the power 0 is 1. Any number times 0 is 0. So 0. Okay, so let's just do 0 times 1. I want you to understand it step by step, okay? Okay. Plus 2 raised to the power 1 is 2. So times 0. 0 times 2. Plus 2 raised to the power 2 is 2 times 2, which is 1 times 4. Because 2 raised to the power 2 will give you 4. I hope that much you remember. So we move on to the next one. Plus 2 raised to the power 3 is 8. So 0 times 8. Plus 2 raised to the power 4, 16. 1 times 16. Plus 2 raised to the power 5, 32. So 0 times 32. Okay. 2 raised to the power 6. 2 raised to the power 6 is 64. So 0 times 64. Plus 2 raised to the power 7, 128. So 0 times 128. Okay. So any number times 0 is 0, right? So you know we'll get 0. I'm not going to write all of them again. So this will give you 0. This will give you another 0. But this will give you 4. So let's write that 4. This will give you 0. This will give you 16. This will give you 0, 0, 0 again. So 16 plus 4, you get your 20. Which means this base 2 that we got by calculating like this is right, because this is the base 10 form, and that is what we have in our IP range 20 over here. Okay, so 0 means as we were getting zeros over here, it means you get 0, 0, 0, 0, 0 throughout. So you can just put the zeros there. 3. Oh, why do I keep using dots? Sorry. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now 2. When you go by this and you calculate the 2, you get and then so you can go through this method to try on your hands on several numbers, or you can try your hands on even the 2 to see if you understand how to convert to base 2. Okay, so this is the value you get. Now, as I was saying earlier, if you see slash 24 here, it means you are using 24 bits. Now when you count these, right, this is 8, this is another 8, this is another 8, and like that, this is another 8. So 8 plus 8 plus 8 plus 8, that will give you 32 bits. So when you are doing slash 24, it means you are using 24 out of this 32 bits for the network, and the remaining 8 for the host, and that's what you divide. So 8 plus 8 plus 8, so that means all these are for the network, and this is what you are dealing with. Now, to calculate the subnet mask, right, when you look at it from here, you realize that when you say /6, for instance, means you are using 1, 2, 3, 4, 5, 6. You are using this for the network and the rest for the host. And this can be found within the first octet. So the first 8 before the dot is the first octet. So the 8 is an octet. So when you count 1, 2, 3, up to 8, you get the octet, and then when you continue, you realize that this will be 9, 10, 11, 12, 13, 14, 15, 16. So these ones too, from 9 to 16, are also within the second octet. So note that if you are using any slash from like the second octet, let's say you are using slash 13, all that you are saying is that you are within the second octet, alright, but then all the others from the 13th to the first should be used for the network, and the rest should be used for the host. So it tells you, the table just tells you where you stand, right? And you know the numbers. You can calculate 1, 2, 3, 4, 5, 6, 7, 8. So 8 ends the first octet. That's why I've arranged them here for you. So the first octet is up to 8. The second octet continues to 16, to 24, to 32. Now, to calculate the subnet mask, from here, when the entire octet is taken, right, /8 /16 /24 /32, that means they, like, /8 means all these, /16 means all these in the second octet and the first, /24 goes like that. So all of them are full, right? You are using everything in full. So when you are using everything in full, it means you have 255 for the subnet mask. The highest number you can get for the subnet mask is 255. This is the table I want you to understand. So if you look at the subnet mask over here, you have 255.255.255. That 255 is the highest you can have in each octet. So if it's /32, it means that you've used all the bits for the network. So it means the subnet mask will be 255.255.255.255. It means you've filled all these sides. So you have all of them full. Now we are going vertically, okay? So how to simply calculate it? You move in base 2, okay? From here, this vertical line, 255. Coming back, you'll be reducing it up to the left side. So if it is not full, then you are deducting some from it. So minus 2 raised to the power 0 over here, 2 raised to the power 1, 2 raised to the power 2. You know, whatever you are counting, you have to start from 0 when you are converting. 2 raised to the power, okay, let me just type everything, minus 2 raised to the power 3, minus 2 raised to the power 4, minus 2 raised to the power 5, minus 2 raised to the power 6. Okay, so these are all the verticals, the vertical lines that we have. So if the octet is full, that is if the octet is /8 /16 /24 /32, it means the subnet mask is going to have, if it's /8, it means the first octet is 255, and that is it. The rest are 0. So 255.0.0, because you are within just this octet. So you get 255, and then the rest are .0.0.0. If you are, let's say, in /24, right, it means you are using all these. So all of them, the first octet becomes 255. So you get 255. So you get 255.255.255. Then you get .0, because you've not reached this octet. You've not used this octet yet. So that's how we calculate the subnet mask. So now from the 255, we are trying to figure out if it's any of these slashes, the number that you get for the subnet mask, right? So that's why we are doing these calculations. So here is 255. Now here is 255 minus 2 raised to the power 0, which is minus 1. So it will give you 254. Then 2 raised to the power 1 will give you 2. So 254 minus 2 will give you 252. Like that. So 252 now. 252 minus 4 will give you 248. 248 minus 8, 240. 240 minus 16, 224. 224 minus 32, 192. Hey, math. 192 minus 128. Oh, sorry, 64. 64. How did I hope you were able to see this mistake. If you're able to see it, I'll be really glad. It means you were following. So you get 128 here, rather. Okay, so now let's say this is rather /7, right? The anthem. It means you are reserving 7 of the bits, 1, 2, 3, 4, 5, 6, 7 for the network, and the rest for the host. So the subnet mask will be /7, what we have here, 254, and because the /7 is in the first octet, you put it on the first octet, which is 254. Then the rest will be zeros because you've not come here yet. This is where /7 is. So you just get stuck from the first octet. Now you get 254 here, and that is it. .0.0.0. Everything is 0. The same way, if it's, let's say, /21, right? It means you are going to get 255, because it means all these are part of the network. So all these are gone. 255 dot all these 255. Then when you get to the third octet, where the 21 is, you replace it with the number we have, which is 248. So if it is /21, right, your subnet mask will now be I can't find space on this thing. 255.255 We are using /21. So now when you get to the third octet, you change it to the number below. So 248.0, because you've not reached here yet. So the same way, if let's say it's /25, if it's /25, it means 255.255.255, you are within here, then you change it to what? 128. So you get, if it's /25, you get this 128. So up until this point, I hope you understand how to calculate the subnet mask. So let's change it back to 24, what we are using. Okay. So this, say it with me, with our subnet mask. Let me just use SM to replace it. Subnet mask for /24 is going to be 255.255.24 is here. So it's 255.0 because we've not even entered the fourth octet. So that is our subnet mask. We have to now find the first IP address, which is always reserved as the network IP. And to do that, we have to perform an AND operation between the IP range address, which is 20.0.2.0. I mean, what we have here, right? What we have here, we have to perform an AND operation between that and the subnet mask. So, like I said from the beginning, everything you are doing, you have to understand the base 2 formula. So you convert it to base 2, then you do it and you convert it back to base 10, because everything is in bits, right? And bits are zeros and ones. So everything has to be in base 2 to work on them. So when you convert the IP range, we converted it initially and we got this. So put it here. And the subnet mask, you can do it at your end, but when you do it, you are going to get 111111.1111.1111 dot 1111.1111 dot 0000000. Thank you. Yeah. So rules for AND operation. This is the only maths where we tell you that 1 plus 1 is 1. 1 plus 0 is 0. 0 plus 1 is 0. 0 plus 0 is 0. That is the rule. Those are the rules for performing an AND operation. So it's like 0 and 0, more like true and false. So to calculate the first IP or the network IP, let me just write network IP. You perform the AND operation. Let's go together. So 0 and 1 will give you 0. 0 and 1 is 0. 0 and 1 is 0. 1 and 1 is 1. 0 and 1 is 0. 1 and 1 is 1. 0 and 0 is 0. 0 and 0 is 0. Dot. 0 and 0 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. 1 and 1 is 1. 0 and 0 is 0. Dot 1, 2, 3, 4, 5, 6, 7, 8. So this is our first IP, which is reserved as the network IP. So you convert this back to base 10 to be able to write it out like this. Okay, so that's what you are going to get, and that is the first IP address, but it's not the first usable, right? So the first usable IP is the IP address that comes immediately after the network IP or the first IP. So that one will be 20.0.2.1, right? So now let's calculate our broadcast IP. The broadcast IP is the last IP address. Now, to calculate the last IP address, we just switch on all the host parts of the IP range. When it's 0, it's off. When it's 1, it's on. So, as I have mentioned earlier, when it's /24, it means you are reserving 24 for the network and the rest for the host, right? So to find the last IP, just switch on all the hosts, the parts that you are keeping for the host. And when you calculate it and convert it back to base 10, you will get the correct IP as the last IP. So now our IP range is this, and we are saying that we are reserving this for the network, so that we cannot touch. We'll keep it intact. Dot the rest that we are reserving for the host, let's switch it on. So that means they will all turn into ones. So 1, 2, 3, 4, 5, 6, 7, 8. So when you convert this to base 10, you are going to get 20.0.2.255. You can do it at your end. So that is the broadcast IP, which is the last IP address, and the last usable IP address is the one that comes immediately before the broadcast IP. So now with this information, let's try to complete our table. So we first found our subnet mask, which is, so the first IP was also calculated based on the AND operation that we performed on the IP range and the subnet mask. So we got this, which is, so the first usable IP is automatically 20.0.2.1 because that is what comes immediately after this IP. Then the broadcast IP, which is the last IP address, we also calculated it over here by switching on all the host bits. So we got, so the last usable IP is the one immediately before this. So you get, okay. The second IP, which is the first usable IP, is reserved for the AWS router, right? The first IP, which is the network IP, is not usable. Now this is general subnetting, right? You get the network IP, the subnet mask, the broadcast IP, the last usable, first usable. But then when you are doing this in AWS, note that the first usable IP is not really usable for you because it is reserved. That in the second and third. So let's copy this one here, and let me just name it as reserves. The second one can also not be used. Reserve 2, which is the second usable, is also reserved for DNS, and so is the third. So this is applicable when you are doing this within AWS. Just note that the first usable IP is not really usable by you because AWS automatically reserves it for the router, and then it reserves the second usable for DNS, and just reserves the third usable for future use. So indirectly, these three are not usable. The first IP is also not usable because it is kept or reserved for the network IP, right? So 1, 2, 3, 4, 5 are not usable, which brings us to our next concern, that is to figure out the total number of hosts that we can get. Now I think I'm going to say this again for the last time. When you see /24, it means you are reserving 24 bits out of the 32 bits for the network and the rest for the host. So now to calculate the total number of hosts, what do? You subtract the 24 from the 32, and the result, you do 2 raised to the power the result, right? So 32 minus 24 will give you 8. 2 raised to the power 8 is, I think we have it here somewhere. We don't have it. 2 raised to the power 6 is 64. So 2 raised to the power 7 will be 128. 2 raised to the power 8 will be 2. I have a calculator. Oh, what is it? 256. Okay, so just know that out of the total host, you are reserving 5. So 256 minus 5, you get 251 to use to create your subnets and to allocate to your hosts and all that. So this is when you are working with AWS. But if it's general networking, then you don't need to reserve these 3. You get the 256, you reserve the broadcast IP, the network IP, and you have 254 to use. Okay, so the same way, if the slash was, let's say, /3, you will get 32 bits minus 3. 32 minus 3 will be 29. So you get 2 raised to the power 29. And that will give you this total. So you can, let's check the table to see if we have the same thing. 53687. 53687. Yeah, I can't see 0912. Yeah, so that's it. So when you check the table, you see that that is the total number we have here. And when we did for the /24. So /24, let's check /24. Yeah, /24 is 256, which means we did it right. Okay, so in order to be sure that the calculation you've done is correct and you understand everything, you can also cross-check using the calculator, the CIDR calculator. So let's put in our values: 20.0.2.0/24. Okay, so the subnet mask is 255.255.255.0. Let's see if that's what we got. 255.255. The first IP is the network IP, and that is what is represented as the CIDR base IP on the calculator. So when you see it, don't get confused. So that's what we have here: 20.0.2.0, 20.0.2.0. Okay, and the broadcast IP, which is the last IP address, last IP broadcast, 20.0.2.25, 20.0.2.25. Okay, and then total number 256, the first usable .1, the last usable 254. So basically, I think that's the same thing we have here.